Hi, welcome back to this channel. We are still in chapter amines. We already went through the Hinsberg test and also the identification test for the anidine. So in this video, we will go in focus on the nitrous acid test and also the formation of dye through the coupling reaction. Basically, the reagent for the nitrous acid is the sodium nitrite with the HCl, which we're going to prepare them in situ so that we can produce HNO2 and NaCl. Okay, so and then the condition needed for nitrous acid test is always 0 to 5 degrees Celsius. If it is primary aliphatic amine, basically we looks like we are taken out the NH2 and then we replace with the OH, Cl, and then also we'll remove one hydrogen so that can form alkene. At the same time, the gases, nitrogen gas will be released, at where we can state the observation is bubbling of gas from clear solution. So let's look at the example here. Like just now we say the NH2 going to replace with the OH, and H2 also will replace with the Cl. So you imagine if the CH3, CH2 and H2 is taken out, so the CH2 has not have enough bond, so it will become carbocation ion. So to form the alkene, we need to deprotonation. So for sure, we're going to remove the H plus next to the carbocation ion. So make this hydrogen from 3 hydrogen will become 2 hydrogen. So we'll form double bond. So the carbocation ion initially have 2 hydrogen will still remain the same. So from here, we know that primary aliphatic amine will give bubbles of the gas. Okay, so at the same time, maybe you can try to draw one table which consists of primary, secondary, and tertiary amine, and then you will have aliphatic amine and also aromatic amine. So for the primary amine, we already have the idea that the observation is bubble of gas. Okay, just recall, just now we say that we need to write out there is primary, secondary, and tertiary amine. For the aliphatic amine, primary we will see bubble of gas. Okay, so for the secondary aliphatic amines, we'll build nitrosol, which is yellow oil. So in simple words to say, we can see here the hydrogen will be replaced by the NO. So look at another example here, hydrogen replaced with the NO. You can put the NO in nitrogen double bond O, double bond with oxygen. So from here we have the conclusion that secondary aliphatic amines will always produce yellow oil. And the equation also very simple, just the hydrogen you replace with the NO. Okay, before we proceed with tertiary aliphatic amine, as like just now, primary amine, for aliphatic, we were able to see the bubbles of gas. For the secondary amine, we will get yellowish oil. So now we will proceed to tertiary amine. Due to the tertiary amine does not have the hydrogen, so this is the base, and then the nitrous acid will be the acid. So acid and base basically will produce the salt. So if it is the salt, so we will get the clear solution. So basically you will add on the HCl and also the NOCl negative. So you look at here also the structure of the amine maintained, and then you just add on the H plus and Cl minus, and then same case happen to the NOCl. So the structure of the amine basically you maintain, and then we're going to add on the NOCl negative. So the positive charge belongs to the nitrogen because nitrogen consists of 4 bonds. Okay, so now is the time to continue with the primary aromatic amine. So before we continue again, primary, secondary, tertiary amine. So we already went through aliphatic alcohol. For primary, we will get bubbles, gas. Secondary, we will see yellowish oil. For the tertiary and aliphatic amine, we will get clear solution. Okay, so now we're going to continue with the aromatic primary amine. So the very common primary aromatic amine will be the aniline. So aniline react with the nitrous acid at 0 to 5 degrees Celsius. We're going to produce the benzene diazonyl salt. Okay, so basically, like we mentioned, we focus the difference. The NH2 will replace with the N triple bond NCl negative. When there is 2 nitrogen get to each other, basically we can consider it is diazole. Okay, and then with the side product NaCl and also the H2O. So for this primary aromatic amine, we will get clear solution, or sometimes you maybe will see in the question that will mention no bubble gas is released, especially you are comparing with the primary aromatic amines. So next, we will go into the secondary aromatic amine. So secondary aromatic amine is exactly similar with secondary aliphatic amine, at where the hydrogen attached to the nitrogen will replace with the NO, which will known as nitrosol. Another example over here, the H replaced with the NO. So we will get the yellowish oil. Okay, tertiary aromatic amine basically will yield color solid or the color precipitate. Okay, at where the nitrosol group will attach to the para position. So if you still remember, we learned the para position in chapter benzene, which is 1,4. So if you notice that the tertiary amine will maintain the same, however, the hydrogen at the para position will attach to the NO, which is the nitrosol. So if you look at here, para basically is the opposite from the functional group. So we'll replace with the N double bond O. So with this, we will get color precipitate. So from here, we can do a very quick conclusion. Primary, secondary, and tertiary amine. For aliphatic amine, we will get bubble gas. For secondary aliphatic amine, we will have yellowish oil, similar with aromatic amine. Okay, however, for primary aromatic amine, we will not see bubble gas. While for the tertiary aliphatic amine, we'll get clear solution. While for the tertiary aromatic amine, we will get color precipitate. So do remember the observation for the nitrous acid test. So we will continue with the tutorial question, which will try to apply the nitrous acid test. Okay, let's continue with tutorial question number 10. If you still remember, in the previous video, we already discussed this question. However, in last video, we focused on the Hinsberg test and also the identification test for the aniline. So in this video, we focus on the nitrous acid test. So we try to see whether we're able to use nitrous acid test to answer this question. So as usual, question asks us to give a chemical test, give the observation and also the equation involved. So will be depends on you which chemical test that is suitable. So if you still remember last night, we used question 10a, we used the identification test of the aniline to differentiate ethanamine and aniline. So today we are going to try to write the suggest the chemical test, which is the nitrous acid test to differentiate the ethanamine and also the aniline. So ethanamine, we know that there is a nitrogen, and then this nitrogen going to have 3 bonds. So ethanamine consists of 2 carbons. So one of the bond will bonded to CH2, CH3, and another 2 bond will bonded to hydrogen. So this one is primary aliphatic amine. So if react with the nitrous acid NaNO2 with the pressure of HCl 0 to 5 degrees Celsius, like previously we mentioned, the NH2 basically will be replaced by CH3, CH2. Okay, the NH2 will be replaced by the OH, and then another one will be CH3, CH2 replaced with the Cl, and another one we're going to remove the hydrogen, so it becomes CH2 double bond CH2, and we still remember that for primary aliphatic amine it will given off the nitrogen gas, and we can see the observation for this reaction will be bubble gas are released. Okay, then the second one we are going to do for the aniline. So aniline with a benzene ring attached to a nitrogen and then with 2 hydrogen. So for this one, it is primary aromatic amine. So the same thing, we are going to react with sodium nitrate HCl 0 to 5 degrees Celsius. So for this one, we will get benzene ring and then the N with triple bond N. The nitrogen with 4 bonds will have the positive charge and then Cl negative. Okay, when this happens, okay, at the same time we will have the NaCl and water. So from here we know that there is no nitrogen gas is involved. So you can write down observation is no bubble gas release, because we are comparing primary aliphatic with primary aromatic amine. Or you also can mention clear solution is formed. Okay, without wasting the time, then let's do the N-methyl ethanamine. So again, we start from the parent ethanamine. We have ideal have the nitrogen, and then going to have 3 bonds. One of the bond will bonded to CH ethane. So that means ethyl CH2 CH3, and then we have methyl attached to the nitrogen CH3. So and then this one is the hydrogen. So from here we know this is the secondary aliphatic amine. So if react with NaNO2 with HCl 0 to 5 degrees Celsius, so we know that the hydrogen will going to replace by the NO. So let's continue here. Nitrogen, CH2, CH3 we maintain, and then here we have CH3, and then this one we have a bond. So this bond will going bonded to the NO. So for this, the observation will be yellowish oil. Yellowish oil, sorry. Yellowish oil. Okay, so from here again we can say that the hydrogen is replaced with the nitrosol. Okay, then now we continue with the third another amine, which is N,N-dimethylmethanamine. So we focus on the parent, which is amine with 3 bonds, and then the parent is consists of 1 carbon. So and then we still have another 2 methyl, and then both are attached to the carbon. So for this, we have the idea this is the tertiary aliphatic amine. So if you react with NaNO2 HCl, so we will going to have CH3 nitrogen, CH3, CH3, and one of the bond of the lone pair of the nitrogen will share electron with the hydrogen from the Cl and then form a charge Cl negative. So for this, we will get clear solution. Okay, so I think we able to prove to you that for the question number 10, even though the question is suggest a chemical test, but actually there are more than one option sometimes. So to pay attention to the chemical test. Okay, tutorial question 11. X is a aromatic amine with the formula C6H7N. So when the number of carbon and hydrogen is quite similar, basically we know this compound consists of one benzene ring. So and then we have the nitrogen. So since the question is saying aromatic, so that means this nitrogen going to attach to the benzene ring directly. So and then we know that nitrogen always have 3 bonds, so means still need another 2 hydrogen. So and then in the benzene ring here we have 5 hydrogen, so 5 plus 2 7. So this already get the structure of X, and then we need to name. So this compound is known as aniline, second mark. Okay, and then going to from the benzene, we going to produce the aniline. So basically, if you still remember in the tutorial question number 6, we are basically answer this question as well. Only at that time, they give us the reaction pathway and then we suggest the reagent. So for question 6b, so from the benzene, as we know, benzene have 4 reactions. The only reaction that will involve the nitrogen, which produce the nitrobenzene, is when the benzene react with concentrated nitric acid in the concentrated H2SO4, and then the condition is 50 to 55 degrees Celsius. And then the nitrobenzene going to undergo reduction. So this reduction process is very specific at where we need to use a metal to carry out the reduction process. So stannum in concentrated HCl, at where the NO nitro will become NH2, at where we're going to lose oxygen and gain hydrogen, which is equal to the simple definition for reduction. Okay, so now we are going to proceed to C. Bromine water can be used as a chemical test to differentiate the X and also benzaldehyde. So X is the aniline, so the observation for X will be white precipitate is formed, while for the benzaldehyde there will be no white precipitate is formed. Okay, and then we need to write the equation. So here I just will very quickly, we just draw the aniline. Okay, bromine water, so we have Br2 equals, and then we know that for this one, similar as the phenol, the Br will attach to carbon 2, carbon 4, and also carbon 6. So, and then we have the HBr as the side product, and then with the observation, white precipitate. So the benzaldehyde, okay, we try to write another equation over here. Benzaldehyde is a benzene ring bonded to C double bond OH, because we know this C double bond OH is the functional group for the benzaldehyde. Sorry, it's not benzaldehyde, it's benzylamide. So I need to erase this structure, benzylamide. So amide is the one which going to have C double bond O and H2. So since this one will not react with the bromine water, so you can just write down no white precipitate. Okay, and then don't forget, need to still put bromine aqueous. Okay, so we will continue question D in next slide. Okay, proceed to question number 12. A compound with a molecular C7H9N. So again, the number of carbon is more than 6, and then the ratio carbon towards hydrogen is almost in the ratio 1 to 1. With these two information, basically we know there is a benzene ring. Okay, however, now here we have 7 carbon. Benzene ring only have 1 carbon. So that is why they might have a few possibility. 1 carbon over here, it can be CH3, and then we will have the NH2 and another bond. Or we can also have CH2 and H2. Or we can also have this structure NHCH3. Okay, and then if this one is 1, 2 position, so maybe you will also think about how about 1, 3 NH2, and then 3 CH3, and also 1, 4. Okay, so with this first sentence, up to here, we roughly will have the idea. It will consist of these 5 possible answers. Okay, so we need to continue to do the reading. Okay, form clear solution when treated with benzene sulfonyl chloride in the presence of KOH. So when we have the clear solution, so basically we will get the idea of the primary amine. Because when we see this benzene sulfonyl chloride, basically we know it is a Hinsberg test. So it's for the Hinsberg test, primary we will have a clear solution, and then we have precipitate after the HCl is added. For the secondary, all the way we will get the precipitate, while for the tertiary we will have 2-layer solution, and then after HCl added we will get the clear solution. So up to here now, seems like we have the clear solution, so looks like it's primary. So let's double confirm. After adding the HCl, will produce a white precipitate. So from here, definitely we know that the C7H9 definitely is a primary amine. Okay, so then now we try to eliminate the some of the structure that we draw just now. So from here, we know that this one we will consider as primary amine. This one also will consider as primary amine. This one is secondary amine, and this one also will consider as primary amine and primary amine. Okay, so definitely the second one is out. Then we continue with the next statement. When C7H9N treated with nitrous acid, no bubbles of gas released. So then now here we know this is the primary aromatic amine. So from here we have 4 structures. This one primary amine is not the answer because the nitrogen is not attached directly to benzene ring. So we have 3 possibilities, 1, 2, and 3. So the question asks us to draw all the structural formula. So each of these structural formula will going to have 1 mark. So here we have 1. And then here we have another 1, and also here we have another 1. So all together we're able to we able to suggest three structural formula based on the observation given. Okay, so if you still felt that to writing the equation is quite challenging for you, so never mind, at least you try to remember the observation first. Then only you proceed with the writing the chemical equation. Okay, let's continue with writing the equation involved in the above reaction. So the first reaction that carry out is they will react with the benzene sulfonyl chloride with the presence of KOH followed by the acidification. So we suggest three structural formula above. So basically you can choose either one of them, which the benzene ring and H2, and then we choose the one with the methyl group at the opposite position so that we have more space to write the substance over here. So and then plus benzene sulfonyl chloride. Okay, so basically we know that one of the hydrogen and from the NH2 and the Cl from the benzene sulfonyl chloride will be taken out. So basically they will only left one hydrogen in the benzene amine. But this hydrogen is acidic hydrogen which will react with the excess KOH and make the structure the benzene ring, the aniline. So only have the nitrogen, and then over the opposite here is the CH3. So and then this bond which break down will bonded to sulfonyl and then benzene. So because of the nitrogen only have two bonds, so it will have the negative charge. And then the KOH, the K plus will attracted to the N negative. So next we will continue with the acidification. So when this happens, the CH3 position maintained, the benzene ring maintained, the nitrogen is maintained, but the K plus now is replaced because they already react with the HCl to form KCl. So the hydrogen will bonded to nitrogen here and then still connected to S sulfonyl and then connected to the benzene. So from here we will get the clear solution, and then for this one we will get the white precipitate. So we already write the equation for the first one. So in next slide we're going to write the equation when the 4-methyl aniline react with the nitrous acid. Okay, now we are going to write the second equation for the 4-methyl aniline react with the nitrous acid. So because this is the primary amine, so NH2CH3. So when react with the sodium nitrite with the presence of HCl with 0 to 5 degrees Celsius, the methyl group will be maintained, but the aniline will become N triple bond N, and then with the Cl negative. So the nitrogen which with 4 bonds will become the positive. So here we will write down no bubble of gas release. No bubble of gas release. Okay, now let's continue to tutorial question 11D, which are the two questions that we're going to discuss. Basically, is more focused on the usage of the diazonium salt. Okay, so now we still look at here. Y is an orange precipitate, orange color azole. So with the following, so means that this is the structure for Y, and then we want to show how this this azole compound can be prepared from X. So if we recall back the X in the question 11, it is referred to aniline. Okay, so when it is about the azole compound, so please always you start from the aniline and then react with the nitrous acid. Okay, as here, the aniline react with the nitrous acid at 0 to 5 degrees Celsius will able to form diazonium salt. So here make sure it is triple bond N. The nitrogen with 4 bonds will have positive charge and then Cl negative. Okay, and then this diazonium salt will going to react with the phenol. Okay, so basically we will get the idea. This part is from the, okay, this part is from the diazonium salt. Basically is over here. Okay, and then they are going to attach to the phenol at the para position, okay, which is over here, para position. Okay, so if you look at here, para 1, para position, so it's the opposite side, which is this one here. So and then they will bond it and then form the azole compound. So this azole compound is the orange color. Okay, the last question that we're going to discuss in this video is tutorial question 13. We need to start from the aniline and then we need to write the synthetic pathway to produce the chlorobenzene. So you can refer to the notes here. If we have the aniline, okay, so we start from here when we have the aniline, which will react with the nitrous acid, NaNO2, HCl, and then 0 to 5 degrees Celsius, it will form the benzene diazonium salt. So because we want to produce the chlorobenzene, which is this one, chlorobenzene, so that means the benzene diazonium salt later they will react with the copper chloride to form chlorobenzene. Okay, then the second part of the question, we are focused on the azole compound. So if you still remember, this azole compound is similar with the question 11D that we just discussed previously. So again, show you over here. You can refer to this slide in your lecture notes. The aniline basically again react with the NaNO2 in HCl, 0 to 5 degrees Celsius will produce benzene diazonium salt and then react with the phenol and attach to the para position to form azole compound. So then the question also asks us, what is the color of the azole compound? So the color is orange color. Okay, so basically means that they only ask you the B only. And then what is the usage? So since it is a color, so means that it functions as the dye. Okay, so basically we already finished chapter amine. So in next video we're going to discuss the objective question. So that's all for this video and thank you. See you in next video. Bye bye.